Geometry, Chapter 1, Section 4, Polygons. So the first idea is a polygon. A polygon is a closed figure in a plane, formed by connecting line segments end to end, with each segment intersecting exactly two others. Each line segment is called a side of the polygon. Each endpoint where the side meets is called a vertex of the polygon. So we can see here, these are all polygons. Here, you have not polygons. So on the polygons, you'll notice that each segment ends intersecting exactly two others. So look, intersect, 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 intersect. So you can see they never intersect more than two other segments. Now, not a polygon, you notice, hey, look, it's not even closed. Everything has to end up being closed. Here, these sides intersected three positions. On this one, you've got a curved side. It's not a line there. So here we've got your vertex, and these are the sides. So vertex, 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 side, 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 side. The name of a polygon is done by listing all the vertices in consecutive order. So if I start at A and I'm going clockwise, A, B, C, D, E. Well, if I started someplace else, let's say I started at D, and went counterclockwise, D, C, B, A, E, as I did here and here. Not a valid name would be A, C, E, B, D. Well, let's look at that one. So I go from A to C to E to B to D. I'm not going in any consecutive order. That's not a legal name for this pentagon here. The diagonal. The diagonal of a polygon is a line segment that connects two non-consecutive vertices. So you can see the diagonal connects D to B. I also could draw a diagonal going from D to A. This here is not a diagonal. That's called a side, D to C. Diagonals go to non-consecutive vertices. Now note, a triangle does not have any diagonals. Only polygons with 4 or more sides can have diagonals. Well, why is that? Well, if we draw a little triangle, if I try to go from this vertice to another vertex, non-consecutive vertice, well, there is none. Those are the only vertices it can connect to, which are both sides. So a triangle does not have any diagonals. Convex or concave. A polygon is convex if no diagonal is outside the polygon. A polygon is concave if at least one diagonal is out of the polygon. So you can see in this first one's convex, I drew all the diagonals. You can see they're all inside the polygon. Concave, look at this. These diagonals are outside of the polygon. So convex, the diagonals are inside. Concave, you have at least one diagonal that's outside the polygon. Congruent polygons. Two polygons are congruent if and only if they're exactly the same size and shape. This will mean that every corresponding angle and side is congruent. So here we've got ABCD is congruent to FGHE. That means that this angle, angle A, is congruent to angle F. Angle B, congruent to angle G. Angle C, congruent to angle H. And then angle D, congruent to angle E. And then also, all of our sides are congruent. So side AB, FG, CB, and so forth. So congruent polygons means every angle and every side is congruent on the corresponding polygons. Equilateral polygons. All the sides of the polygon are congruent. So all the sides are congruent. Now, in the case of a triangle, it also means all of the angles are the same. This is only in the case of a triangle. So in a triangle, if the sides are congruent, the angles are congruent as well. That is only true for a triangle. Equal angular polygons. Equal angular polygons, all the angles of the polygon are congruent. In this case, I have a rectangle here. All the angles are 90 degrees. In the case of a triangle, it means all the sides are the same as well. So we got, in the case of a triangle, we have this. The sides are congruent, the angles are congruent. But that, again, only works in a triangle. Regular polygons. On a regular polygon, all of the sides and angles are congruent. So here, all my sides are congruent, and all of my angles are congruent. So that's a regular. So a regular polygon is equilateral and equiangular. So let's look at a little bit of algebra review. Here we've got a polygon. It has a perimeter of 100. Remember, perimeter is the length of all the sides added together. So we're given the measure of CD is twice the measure of BC. So if I call BCX, CD is twice that, so it's 2x. CD is congruent to AB, so CD is 2x, AB's got to be 2x. The measure of ED is 4 more than AB, so if AB is 2x, ED is 2x plus 4. And then the measure of AE is 12. Determine the length of each segment. Well, I know these, all of them add up to 100, so I'm just going to do it like this. 2x plus x plus 2x plus 2x plus 4 plus 12 equals 100. I just added them all up. This plus this plus this plus this plus this adds to 100. Well, 2x plus x plus 2x plus 2x, that's 7x. 4 plus 12 is 16. Subtract the 16. 7x equals 84. Divide by 7. X is 12. But I'm not done. I got to plug this in. So CB is 12. 2 times 12 is 24. So CD is 24. 24. 2 times 12 plus 4. And this one's 28. And that's the end of this lesson.